let's see a couple of specific examples. For f of xy equals square root of 4 minus x squared minus y squared, let's evaluate f of 1, 1, and then we'll find and sketch the domain. F of 1, 1, that means put a 1 in for both x and y. So I'll have 4 minus 1 squared minus 1 squared, and that would be square root of 2. And what that tells us is that if I were to take the point 1, 1 in the xy plane, the height of the point on the graph, so in other words, the point on the surface that is the graph of this function, would be square root of 2 units above the xy plane. Now, what all xy's are allowed to be put into this function? That's the domain. So let's figure out what the domain is. By the way, this little picture that I drew here, that's just where one single point goes. As you can imagine, it's going to be very difficult to figure out what the surface looks like by just plotting points. So don't worry about that right now. In a little bit, I'll show you how to figure out what the surface looks like. We're not there yet. Right now, we're just getting the idea that the function output tells you how high the point is above or below the xy plane. Okay, back to the domain. So for the domain, we need the input to not give us a negative under the square root. So I need 4 minus x squared minus y squared to be greater than or equal to 0. Now, how are we going to sketch this on the xy plane? Well, let's add an x squared and a y squared to both sides of this little inequality. And that will give us 4 is greater than or equal to x squared plus y squared, or as I would prefer to think of it, x squared plus y squared is less than or equal to 4. Now, hopefully that looks to you like a circle, and we're in a position here where we can use our previous knowledge of how things look in the xy plane, because remember, the domain sits in the xy plane. So if I just ignore the z-axis, which we usually do if we're just sketching the domain is going to be a circle centered at the origin of radius 2. That is our domain. Oh, and I should say it's just the circle and its interior. We don't usually try to draw the domain in 3D just because it's harder is all. But just to kind of maybe help you get an idea of what this looks like, let me do that. So it's a circle centered at the origin. That's a crummy circle, which exactly illustrates why this tends to be done in 2D. If you're only drawing a 2D figure, might as well do it in 2D. But anyway, if I were to draw it, remember it's sitting right on the xy plane, because that's where our inputs are, their xy values. And so that's how the domain would look in 3 dimensions. But but again, the way when something asks you to sketch the domain, it's just asking you to sketch it in the least number of dimensions you can. So this would be what we're looking for.